Hello friends, welcome back to my YouTube channel. Today I'll be talking about complex number. So the question is, what is a complex number? A complex number is one that has both the real and imaginary part. For instance, if you have this x plus y times I, so this is actually a complex number because x is the real part while y times I is the imaginary part. Now you may be asked to, this is actually a rectangular representation. There is a polar form of this which is derived from the Argand diagram or the Cartesian coordinate. Now this is actually the polar form of this is r cos theta plus I sine theta. This is very important to remember. I'm going to show you how it is derived. Now the other one is you have to know that absolute value, that's what we call absolute value or modulus, is equal to x squared plus y squared. This is very important. You derive using Pythagoras theorem. I'm going to show you too. Now, and the last one is what we call the argument. That argument is actually theta is equal to tan inverse of y over x. Now, I'm going to show you using this diagram. The Cartesian plane. This is the Argand diagram is similar to Cartesian plane. So you know when you have this quadrant, you are plotting in normal graph. You're plotting y against x. So you know that this is the vertical axis is represented by y. That is y. The x-axis is the horizontal axis. So this is the imaginary part. This is the imaginary part, this is the real part. So, and this is the origin. So when you plot this, so the graph is going to start from origin. Now, when you form a triangle here to find the slope, this is going to form a right angle triangle. So this is theta, the angle it makes with the horizontal. So this is y, this is x. So this is what we call the modulus, or the absolute value of the complex number. Now from these three formulas are derived. The first one is, now I'm going to show you, because using trigonometry, so opposite over hypotenuse, this is a right angle triangle. So opposite over hypotenuse, y over r is equal to, opposite over hypotenuse is sine theta. The sine theta, we all know that. And y is equal to r sine theta, making y the subject of the formula, r sine theta. So I'll do the same for x. If you x divided by r, this is adjacent sides, divided by hypotenuse, that is going to give me cos theta. And x is equal to r cos theta, making x subject of the formula. Now, from this rectangular form, if you replace the x with r cos theta, that's going to be z is equal to r cos theta plus I. Remember that y is equal to r sine theta, and there is I already there, so it's going to be I r sine theta. So z is equal to, I'm going to factorize r to have cos theta plus I sine theta. So you can see the polar form of this, how it is derived. So the third one, which is the argument, okay, the third one, which is the absolute value r, is actually derived from here. You know, this is a right angle triangle, this is Pythagoras theorem. To get r, is going to be square root of x squared plus y squared. I will give you r, or absolute value of z. So, and to get the theta, which is the argument, is going to be tan inverse of y over x. This is y here on the vertical axis, x on the horizontal axis. Tan inverse of it will give you the argument. And it's good to remember the trigonometry law, which is this, when you have this is ASTC, all student takes coffee. You know when to subtract from 180 and when not to subtract. Actually, if it falls within the first quadrant, you don't bother, because all is positive This is theta. The second quadrant is 180 minus theta. The third quadrant is minus 180, then put brackets minus theta. It's very important. The fourth quadrant is minus theta. So I'm coming to this. So for me to solve this example here, I will use this, I will apply this. Now the question says convert the complex number in polar form. Convert the complex number, the given complex number in polar form. Now, so for me to solve this, so it means that z is equal to 1 plus square root of 3 times I. So for me, I'm going to get the absolute value of z, or the modulus, which is square root of x squared plus y squared. And you know, this is x, the real part, so y, the imaginary part. So this is going to be 1 square plus square root of 3 square. So this will be equal to 1 square is 1 plus square root of 3 square is 3. R is equal to square root of 4, which is equal to 2. 1 plus 3 is 4. Square root of 4 is 2. So 2 is the absolute value. So remember that this is y, this is x. So I'm going to get the argument. The argument is tan inverse of this. Y is a sod 3 divided by 1. X is 1. So tan inverse of sod 3 over 1 is equal to 60 degrees. And this fall within the first quadrant. So what I need to do now is to convert this. You might just leave it like this or convert to radian. Converting pi degree to radian is going to be theta will be equal to 60 times by pi over 180. That would be pi over 3. 60 divided 180 divided by 60 is 3. So in radian. So now for me to represent this in polar form, it's going to be polar form will be equal to, so remember our polar form as r brackets cos theta plus I sine theta. So now I have r as 2, then brackets cos theta is pi over 3 plus I sine pi over 3. So this is the answer. It's very simple. Then I'm going to solve this again with a second method. There is another method I'm going to use. That one seems complex, but it's easy to me. So what I'm going to do is, we know that I plus 1 plus sod 3 I is equal to the polar form r cos theta plus I r, or rather ri sine theta. This is the polar form. Okay, or I can just write I, both are the same, r sine theta. So in this case, I'm going to use comparison. So, you know, this should be equal to this. Okay, because this is the real part, this is the real part. So this is the imaginary part, this is the imaginary. And this is the second method. I've actually got the answer, which is 2 cos pi over 3 plus I sine pi over 3. That is the answer. That is the polar form. Now I'm using this second method. So I'm going to do comparison. So this is going to be 1 is equal to r cos theta. Okay, and the second one the imaginary part, this is the imaginary part, will be equal to this. So 3 will be equal to r sine theta. I'm going to call this equation 1, call this equation 2. So what do I need to do? I will square this first equation and the second equation, squaring both sides of the equation. So this is the same thing as squaring 1. I'll square this. Squaring this, I'll have r square cos square theta. I'll do the same here. I'll square, so 3. I'll square this. That will give me r square sine square theta. Now I'll solve simultaneous equation. 1 square is going to give me 1. So that is 1 is equal to r square cos square theta. This is, so 3 square or square root of 3 square is going to give me 3. That is equal to r square sine square theta. So I'll add the two equations. Add, okay, in order to find the value of r. So adding this, I'll have, this is 4. 1 plus 3 is 4. So I'll add this, I'll have r square cos square theta plus r square sine square theta. That is 4 is equal to, I'll factorize it because r square is common. That's going to give me r bracket cos square theta plus sine square theta. Okay, so the next thing to do is, remember that in trigonometry, that's cos square theta plus sine square theta is equal to 1. It's a trigonometry law. Okay, so now that means I'm going to replace this here. This is square. I'm going to replace this with 1. So doing that, I'll have 4 is equal to r squared times 1. So I'm going to get to find the value of r, because r squared times 1 is r squared. So to get the value of r, I will obtain the square root of 4. That will give me 2. You can see the long process of getting this modulus. Something I should have used, just like I did in the first method. I used Pythagoras theorem and I got it straight away without wasting time. But it's good to know this step as well. So modulus is 2 now. So what do I need to do again? Since I got modulus as 2, that is the absolute value. Remember that this is the same thing as z. This is z, absolute value of z. Now, the next thing to do is to look for the theta, okay, before presenting this in a polar form. So I'm going to recall this. Let me clean up. Let me clean this. Okay. Let me clean this. So we know that r now is 2. Okay, r is 2. So the next thing is to bring the first equation and replace r with 2. Doing that, I'm going to have 1 is equal to 2 cos theta, which is the same thing as 1 over 2 is equal to cos theta. Okay, making theta the subject of the formula, you divide across with 2. So now I'm going to have to get theta. Theta will give me the cos inverse of 1 over 2. Cos inverse of 1 over 2 is actually 60 degrees. I'll do the same here. Then replace, this is, so 3 is equal to 2 sine theta. Then making sine theta the subject of the formula, I will have, so 3 over 2. Then theta, sine inverse, if you check your calculator, sine inverse of square root of 3 over 2, that is going to give me 60 as well. So you can see the angle, which is the argument, is 60 degrees. That is 60 degrees. So to get the argument, theta is equal to 60 times, because it's in the first quadrant, you don't do further calculation. You can just convert to a radian. Pi over 180, because you're converting angle degree to radian. You multiply by pi over 180. That will be equal to, this will cancel this, 18 divided by 6. That is going to give me 3. So I will have pi over 3. That is the argument. Now, meaning that the polar form of this, which is this, is going to be, polar form is going to be r is 2 cos, put brackets here, 2 cos pi over 3 plus I sine pi over 3. Very simple. Okay, that is the second method. So thank you for watching. I'll be bringing more. Don't forget to subscribe to this channel if you have not done so. Your suggestion is welcomed. Thank you.